Okay, good morning, everybody, or afternoon, whichever the case may be. My name is Mark Mays. I'm a Senior Applications Engineer with Outback Power, and welcome to the string sizing tool for Outback products. So we're going to go and get started, and I'm going to start with the agenda. So the agenda for today is we're going to talk a little bit about some of the sizing parameters for Skybox, our new all-in-one inverter, and some pre-wired flex power systems. And I'm just going to start talking about, just sizing in general to kind of give some context for the string sizing tool. We get a lot of requests for string sizing tools, so I'm sure a lot of you are probably already familiar with it. This is a slightly newer version than what we had distributed in the last couple of months. Then we're going to do like an overview of Outback Solar MPPT DC-DC converters that we have. We have our charge controller line as well as the all-in-one Skybox that has its own DC to DC converter built in. We're going to talk about, we're going to show you the string sizing tool itself. And then we're going to show some examples using our System Edge packages. Okay, so just to give some context, with a battery-based system, there's a lot of different components or configurations, if you will, as compared to a regular grid tie inverter. With the battery-based inverter, typically we will have a backup load panel. So when we lose power, these loads are the ones that are backed up. We have some batteries. We have something called a charge controller, which is a DC to DC converter that regulates and controls the voltage and current coming off the PV array. And then we have to figure out, which module we should use. And what configuration, and that's the main purpose of the string sizing tool. We also have another tool. It's a system sizing tool for doing custom system sizing, and that will be in another forthcoming webinar. And we've had different variations of that over the years, and so we're going to talk about that one in a future webinar for custom sites. And the reason we bring up the System Edge package, just jump to that slide, is a pre-wired system. In this case, we're showing the Skybox, or it could be Flex Power Radian. It also comes with the rapid shutdown for 2014, and it comes with a package of batteries. Okay, so again, if we look over at the bullets over here on the left, we got the energy cell batteries from Outback. Rapid shutdown comes with the optics RA monitoring for free. It's a very nice monitoring and control system that we have. Also, you can download the configuration files. The reason we haven't done that in the past with our pre-wired systems is we didn't sell the batteries as a package, and unless we know how many batteries and what size the batteries are, we can't really configure the system. But since we're selling this now as a package, we can offer the configuration files. So you would download the configuration file. It's a .xml file with the System Edge package as part of the name, and then you would just use the Mate 3 system controller, download the configurations, and you're at least 90% or more configured. Okay, and you get the pricing advantages and the convenience of ordering a single SKU as well. Might also add, I'm getting over a little bit of a cough here, so I might be muting the phone here and there to take a drink of water or not cough in your ears. So if you hear some unexpected silences, that's why. Okay, so here's an example of a System Edge package. Here's our Flex Power Radian. This is a 4,000 watt Radian. with a single charge controller. And if you look at the system over here on the top left, the system number for System Edge, the first number is the power of the inverter in kW. So this is a 4 kW inverter, so we have a 4. The next two numbers is the kWh of the battery. So in this case, we're looking at 19.2, roughly 20 kWh. Then PLR is the type of chemistry. PLR is a float battery chemistry, and that's important to know whether you're in a float application or if it was like an NC battery, that would be like a cycling application, or it could be like a lithium-ion battery. So here's typical runtime, average battery life, array up to 6 kW. We have dual AC inputs, so if you want to add a generator, then you don't need to have a transfer switch, and it's UL 1741 listed, and typically the number of panels, but we're going to use the sizing tool to figure that out. So when we were offering the System Edge packages before, you would need to use like a string sizing tool to figure out, okay, what kind of modules, what's the best configuration of module, and the string sizing tool will help achieve that. Okay, so the charge controller power and current limits with the FM 60 and 80, the maximum VOCs are 150 volts. It actually goes into a standby protection mode at 145 volts. Do not exceed 150. That will almost for sure damage the charge controller. The FM100 has a 300 volt max VOC. The Skybox has a 600 volt max VOC. And if we look at different voltages, obviously as we increase the system voltage, we can get more power out of the array because the current is fixed. And as we multiply current times voltage, then the power goes up. And so most people will go with a 48 volt system. Some mobile applications might go for 24 volts. In general, 12 volts is not a good idea. You really, there's just too much current and not enough voltage to get any significant power out of the system. Okay. So the maximum connected watts is what you can safely connect. A lot of people like to oversize their arrays for winter time or shading issues or whatever. So this is the maximum watts, connected watts that you can have with each of the four MPPT devices. Okay. Oh, one thing I forgot to mention also, if you could hold your questions off till the end. I prefer to catch them all at the end, and there could be some information during the presentation that answers your questions. So we can hold off questions to the end. Okay, so let's go ahead and we'll go ahead and jump into the tool. Looks kind of like this. Let me jump over to my spreadsheet. Okay, so this is what the tool looks like. The blue cells are user inputs. Some of them are drop downs, like for Skybox, we can choose Skybox or any one of the 3 charge controllers. The number of strings, the maximum for Skybox is 2. Let's say I put in 4, it's going to turn red, tell me I've got too many strings. Also, it's telling me I've exceeded the short circuit current of 32 amps. So we'll put that back at 2. And then this tells me how many modules in series. And that relates to this number up here, this 8, the big black 8. Now it's going to show me 3 less and 3 more in series, just so I can kind of get an idea of what that is. This first row below the modules in series is the minimum temperature, VOC. Ideally, we want to see all greens. The caution means just that, caution. So with Skybox, we can only convert 5,000 watts, but we can have up to 6,500 connected. So it's just telling us that, you know, it's okay, it's safe, but just you're not going to get all this power. You're only going to get 5,000 watts. So you're kind of over-connected, if you will. Okay, so then the maximum temp VOC, there's a minimum VOC that we need with Skybox, 250 volts or more. So that's why if we go too few strings, we're just not going to be able to VMP. We'll have it disconnect. And then also over here, I see on the STC array watts. We've reached. In this case, it's red because we're over 6,500. So in this particular configuration, we could go with 7 in series, 8 in series, or 9 in series. Okay. Then the temperature is very important when we're calculating like VOCs and VMPs. So we need to put the temperature. There's a temperature converter in here. So if I wanted to say, okay, what's the equivalent of 100 degrees Fahrenheit? The equivalent is 38 degrees C. So we got a little temperature converter here for those of you that don't operate in the world of Celsius. And then here we have various and sundry preloaded modules. We have over 200 of them. If you don't see, you can add. Here's a couple I added outside here. So we'll go to the module data. So all these ones that are grayed out, you don't have access. These are all protected cells. Here I'm showing an example of a couple that I added after the fact. You can go and add up to, I think, line 500 or so. Add in your own modules. You just need, you don't necessarily need the model number, that's optional. Sometimes a particular brand will have like different modules under the same power. Okay, so then there's the STC watts, the VMP and VOC voltages, the temperature coefficients, and then ISC. And ISC is just making sure that we don't have more short circuit current than the MPP device is rated for. Now, there's another thing that was recently added, and that's the load profile. So the load profile, the reason we added this in here is we want to make sure that that there's a good match between what the customer load is and the package. Now, in this case, we have some lights, some backed up receptacle loads. Anything in this blue field here, you can change. So there's other things you can add on here, computer network. A lot of these things are not real huge loads. We have the refrigerator, which is a cycle. Typically, if refrigerators are not going to cycle for more than 15 minutes out of an hour. I mean, you can change that duty cycle, but that's why this is 6 hours instead of 24 hours. And with the HVAC system, the central air conditioning, heating, I have this on a 20% duty cycle. Okay, so and then you put in the number of days per week the load is on, and then surge multiplier. So typically we use 3, even though it can be much higher than that. The chances of all these loads being on and all the surge loads on at a time probably gives you enough cushion to use 3. We've used 3, and for the most part it's been fairly successful. Also, a lot of equipment, refrigerators and air conditioners have some soft start capabilities to them also that they're adding in these days. Okay, so anyway, you want to go through and come up to your load profile. These with the water pump and clothes washer, typically those are off-grid loads that you don't normally back up or see. To enable those, we just changed the 0 to a 1. Okay, and you notice that changed our load summary. So we have the total continuous kVA. That's all these connected loads. If they were turned on all at once, that's what this number would be. Then the surge is all the connected loads plus the ones that have a surge factor. That's what the total surge kVA is. Then the kWh is how many hours per day are they on, okay? And that's what gives us the energy or the battery sizing aspect of it. So if we were to take a look at this, these are our different system edge packages. There's one on here that I didn't happen to include, I didn't see till later. It's the SE320 NC. And that one is a Flex Power 1 with our 3.6 kW. It's a 120 volt inverter that might suffice in some backup locations, some backup applications rather. So keep in mind that's not on here. So if we were to take a look at this, I'm going to go ahead and get rid of the water pump load. So we're looking at a 6.9, so we need at least a 7 kW inverter, surge load of 19.9, and total kWh of 30. So we've probably pretty much exceeded everything that's available in terms of a system edge package. But the main thing driving that is this one big HVAC load here. And so let me show you what happens when I turn this to a 0. Now my continuous went from 6.9 to 0.9, surge 1.9, and my kWh is 6. So if we just want to back up these kind of light loads, you know, we really, that SE320 FP1 package would probably be enough. However, nearly everybody I talk to wants to back up air conditioning, and one strategy that you might want to consider, since this takes up, air conditioning takes up so much energy, is to maybe think about a compromise. Like you could talk to your customer and say, okay, how about if we go with a 1500 watt mini split and put that in a cooling room? So the family room where the TV and the entertainment system is, we'll just put a mini split in there, a 1500 watt mini split, and that'll be the cooling room as kind of a compromise. Now you're looking at something that's far more reasonable. The total continuous kVA is 2.4, surge of 6.4, and total kWh is 12. So now you could use just about any package up here that you like. The only a little bit of a caution here would be on the Skybox packages. They're the ones that start with 5 kW ones. So Skybox doesn't really have any surge capability to it. However, if you know that your HVAC mini split has a soft start or not much surge associated with it, you might be able to go that route. But let's go ahead and let's pick a one up here. Let's try with the 4 kW Radian. Okay, so one of these starts with 4, so that would either be the 19.2 kW NC package. Now keep in mind, when we look at that package, we size the batteries at 50% depth of discharge. So that's going to be more like about 10 kW. So we're a little bit on the edge there. And so we might want to think about going up to a bigger battery package if we have one. Let's see. So we have the pure lead battery, and we have the NC battery, and we have the lithium battery. So maybe the lithium battery would be the one. This we can use at 100% of its rating. And so we can use that 100% rating. So let's go ahead and say that we're going to use our 4,000 watt Radian, and the dash 300 means the FM100. So let's go back to our string sizing tool, and we're going to switch over to the FM100, and 8 strings is too many in series. Try it 6. So 6 in series looks like a reasonable way to go, but we're only at 4,200 watts. So we could stick at 4,200 watts, but that's a little bit underpowered. So let's see what happens when we increase the strings. So if we add a third string, which means we will need to have some sort of a combiner, then now we're up at, we're kind of oversized a little bit at 6,300. Now we can do 6,500 connected watts, but what happens when we change to a 300 watt system? So with a 300 watt system, now we're kind of dialed in a little bit better. We have maybe a less expensive module. We're at 5,400 watts. So that's kind of an ideal, slightly over. Most arrays don't run above 75–80% efficiency anyway, so probably not a big deal. So that's probably the most ideal. Let's see what happens if we were to go to something quite a bit less. I think there's a Soneva 275. So the Soneva 275, that doesn't really, we're not, we could possibly go 7 in series, but we're right on the hairy edge of, we're actually in the zone where we're kind of in a standby when we get above 290 volts. So that doesn't really give us any advantage other than, maybe if somebody's having a fire sale, some 275s, you still may want to consider, going 6 in series. That's going to give you 4,950 instead of 5,400 watts. Anyway, these are kind of some of the what if scenarios that you can go through with different modules and go from there. Now, what happens if we go to Skybox? Let's say that we're not too worried about that little bit of extra surge. We got a soft start in our HVAC system. Let's see about one of those Skybox systems. So we come up, we have to change that to 2 strings. We're not going to meet the minimum VMP, so we're going to have to increase the number in series. So let's go up, let's say 9 in series. So yeah, so we're looking at 9, 10, or 11 modules in series, so 2 strings of 9 all the way up to 2 strings of 11. So just know that we're going to have, when the array is really performing at STC, those cold mornings or whatever, you're going to be up in that zone where you're probably going to be curtailing the array. So probably 2 strings of 9s, probably the sweet spot, maybe 2 strings of 10, oversize a little bit. Okay, so that's pretty much how this tool works. We are going to have this on our on our website, and at this time, I'll go ahead and open up to any questions. Not seeing any questions. I guess must be very straightforward how to use. And again, you should see this up on our website. If not, contact our tech support group. They can direct you to where this is going to be. And I'll give one more chance for any questions. Hopefully you find this tool helpful. And thank you for attending today's webinar. Okay.